pour ce webinaire. Bonjour à toutes et à tous, bienvenue ce matin pour ce webinaire que nous organisons dédié à la vision industrielle et les solutions que nous proposons. Donc ce matin, je suis Denis Gilardin, directeur commercial de Phytec France, et je serai accompagné pour cette présentation par monsieur Klahr, le responsable de nos activités d'imagerie embarquée, qui nous présentera en anglais l'offre Phytec imagerie embarquée depuis Phytec en Allemagne. Pour le bon déroulement de ce webinaire, donc d'abord savoir que ce webinaire est enregistré, ça vous permettra de le regarder a posteriori ou de le diffuser à vos proches collaboratrices ou collaborateurs. Et par ailleurs, vous pourrez tout au long de ce webinaire nous poser des questions via le chat du webinaire et nous y répondrons en fin de session. Donc, concernant l'agenda de ce webinaire, une vision globale de notre offre en vision industrielle et en imagerie embarquée, un cas d'usage que vous présentera Klahr et en finale, cette session de questions-réponses. En quelques mots, par rapport à Phytec, donc Phytec, nous existons depuis 34 ans. Notre métier, c'est de faire des systèmes on module, donc des solutions de cœur calculateur qu'on va retrouver dans des systèmes embarqués à base des derniers processeurs du moment, les cartes d'accueil qui vont être associées et puis des offres satellites comme l'imagerie embarquée. Activité d'imagerie embarquée que Martine a développée au sein de Phytec depuis 26 ans, sachant que Phytec est une structure d'un bureau d'études et une structure de fourniture de solutions produits d'un peu moins de 400 ingénieurs et techniciens. Notre maison mère et site principal est situé à Mayence, en Allemagne, où nous produisons nos produits, donc fabrication européenne, et on va distribuer, déployer ces produits auprès de nos partenaires et clients en Allemagne, aux États-Unis, en Chine, en Inde et bien sûr en France, puisque nous avons le plaisir de vous présenter cette présentation depuis Phytec France. En complément à notre offre hardware de solutions SOM, de cartes d'accueil associées et d'offres d'imagerie, de solutions OIM, on va accompagner cette offre de solutions de logiciels, de BSP qui vont permettre d'animer ces produits et l'ensemble d'une offre de services qui passe par le support au quotidien à travers notre équipe support, l'intégration de systèmes et des services associés sur de la customisation ou des besoins spécifiques clients. Et enfin, une offre de formation. Je vais laisser la parole désormais à Klahr qui va vous présenter dans le détail notre offre d'imagerie embarquée.
Ja, merci Denis. Et bienvenue chez Phytec. Je m'appelle Klahr. Je suis responsable du département de traitement d'images en Allemagne. Malheureusement, je ne parle pas beaucoup le français. So I hope it's okay for you when I continue this presentation in English. And as Denis said, today I would like to show some of the latest developments and opportunities for embedded vision design. We will have a look on the features of the i.MX 8M+ module for embedded vision, which features can we use and which performance can we expect in practice. And also I would like to discuss some challenges or obstacles in designing an embedded vision system and show some solutions and services of Phytec which can help to accelerate system design. Let's start with a very simple overview over a vision system. We typically have an object we want to visually examine. We need a light source, a lens, a camera, and of course a computer core which somehow has the ability to interface with the camera. And we need interfaces to peripheral components like actuators, other sensors, or maybe a display. And if we combine this all together, that's what we would call an embedded imaging system. So as a definition, we could say An embedded imaging system contains all optical, electrical, and mechanical components needed for a specific task. And it's typically designed and tailored for a specific task, and it also contains the application software for this specific task. Or in other words, an embedded vision system is typically tailored for one specific application. And what are the implications of that? Let's have a look at some examples of embedded imaging system that our customers build with Phytec hardware. And I think what we can see is they are all really different. And in consequence, they all have very different requirements concerning the design. But we still want to obtain a high integration level and a good efficiency, also, or especially, a good cost efficiency. And just to visualize this challenge a little, I put down some of the typical requirements that we frequently face when we design an embedded vision system. No worries, we won't talk about them all, but characteristic for embedded systems are those requirements we see here on the right side. We have to optimize the product for volume manufacturing because embedded devices are typically selling in high quantities. So we have to think about cost control and optimization. Then safety and security aspects might be important when our product is connected to the internet, for example. And we got to think about lifecycle management, update, maybe remote maintenance. So our product will be available for a long time and will have a long lifetime. So the challenges we have to take up with embedded designs are: how can we handle many different requirements at a high integration level, and at the same time develop our products in a short time with minimum effort? And second, how can we minimize the efforts while our product is out in the market over maybe a very long product lifetime? And here I would like to present a concept that helps to achieve that, the so-called make and buy concept. So what does that mean? This is actually pretty simple. The basic idea is to use ready-made modular components wherever this is possible. For example, for the computing core, we can use a system on module, and also we can use an off-the-shelf camera module. That are the components here and here. And by doing that, all we have to do is to design the individual part of our project. And in this concept, this is done by designing a customized application board. This is this here, customized peripherals or application board. And that in this setup also carries the CPU module. And this concept allows us to drastically reduce the complexity of the design. The modules are proven and verified designs, so this is also reducing the design risk. And another benefit we have here with the software, with the CPU module, we get a ready-to-use Linux operation system that has been adapted to the hardware already, a so-called board support package. And this also saves time and money and makes it easier to start into the development. And software development can focus on designing the actual application software. Later, when our product is in production, Phytec supports lifecycle management. We do the product change management for the modules. So that is off from the lists of things that you need to worry about. And the same with the Linux operation system. Phytec provides frequently updates for the BSP so that that's something you won't need to care about neither. And another thing that I think is really good to know is design support. When something doesn't want to work as it is expected, the Phytec design engineers will assist you. We have a team here in France too that you can directly address. And in general, our goal at Phytec is that you can get your product ready as fast and easy as possible. Okay, that was a little about general design, and in the following, I would like to present some of the latest developments of modules and components for embedded vision applications. And I would like to start with a system on module computer board, the phyCORE i.MX8M+. And with NXP's i.MX8M+, we have a CPU core specially designed for vision applications. And let's have a closer look on the features. So here on the left side, we have the block diagram of the processor. And in the table on the right, we see some of the features that are very useful for embedded vision. So first, of course, the CPU cores. The i.MX8M+ has 4 ARM Cortex A53 cores with a frequency of 1.8 gigahertz. I like the A53 core here pretty much because it has a good price-performance ratio and also a nice energy efficiency. There might be cores with more power like the A72, but I think the A53 here that NXP is using is a good trade-off. So for imaging applications, of course, it's important for us to know how can we connect and integrate cameras. And for that, this processor has 2 MIPI SI2 interfaces for camera sensors. And something that is pretty special here, the i.MX8M+ has a dedicated image signal processor for image pre-processing. And this is very interesting, so we will have a closer look on that later. Next, we have a GPU for 3D graphics, which we could also use to do some simple image processing task. Then another IP core that is really interesting for vision applications is the neural processing unit. This accelerates machine learning with a throughput of 2.3 TOPS. And machine learning became extremely popular in the past few years in vision. So later we will also have a closer look on the capabilities of this unit. Some other useful units here, we have a single instruction multiple data unit. We can use this, for example, for certain image pre-processing operations too. Then the video processing unit that can be used to compress image data into H.264, H.265 profiles for streaming them over the Ethernet, for example. Another small CPU core that we can use without the Linux operation system for real-time tasks. And last but not least, the connectivity. I put that all together here in the big box, a wide variety of interfaces. For example, USB 3, CAN FD, gigabit Ethernet with TSN support. So many things that are useful for industrial communications. Okay, that was an overview over the processor. What we really need to decide if we can use this system for a given application is a feeling for the performance. How long does it take in practice to process a given image processing application or a given task here? So let's have a look on that to give you a certain feeling for that. We will have a look on some examples for real image processing tasks. What did we do here? We took the image processing library Helken, which is also available for ARM platforms. You might know Helken as a professional image processing library from the company MVTech. So that's all available for ARM. And for evaluation, there's a demo available named HPeak. And this is basically a collection of round about 40 practical examples. We can execute this on the target ARM platform and measure the execution time. So here on the right side, you can see how that looks like. HPeak uses a given set of images, as always the same ones, so that performance can be compared on different platforms. And here on the lower right in the orange box, I hope you can at least see that a little. In the orange box, there is the execution time that is measured, is shown in the box. So we have the HPeak demo ready to use as an SD card image for our development kits. And that's what I used here to generate a few examples. So what we see here right now is the inspection of the radius of this bondage balls of a chip. Now, green indicates okay, and red is not okay. And the average execution time, as we did that many times to get an average time. So the average time needed here is approximately 4 milliseconds for this example. And important to mention only on the CPU, without any acceleration by the GPU or other features, just here to show the performance of the CPU. Let's have a look on the next example. This is QR code reading, and this takes around about 11 milliseconds. Here in the list, some other ones with similar execution times. For example, the inspection of a punching die or the localization of metal parts, all round about some 10-something milliseconds. So this here is to inspect a tablet blister. Are all the pills in the blister? Are they in the right location? And the average time for this is 60 milliseconds. And next here in the list is an example of a deep learning application, fruit sorting. This takes approximately 170, 180 milliseconds on the CPU. However, for this task, we would probably use a different approach with this processor, because we can use the integrated NPU. So we would rather define a neural network with TensorFlow and use the neural processor. So, and the last example, my favorite example here is recognizing different wine bottles. This task without any acceleration units, round about 300 milliseconds. Well, I think this is fast enough for this application, at least for home use. Yeah, we have measured many other examples. Complete list you will find in the handout that you can download after the presentation. Well, I already mentioned the deep learning example. We would better execute this on the NPU of the i.MX 8M+. So let's have a look on the performance of this neural processing unit next. And here also some practical example. We took some typical standard neural networks that are frequently used for embedded systems. The ResNet50, MobileNet1, MobileNet2. And we took our development kit again and let the network run 1,000 times each on the NPU, and measured the average inference time. And the inference times are summarized here in the table. For the ResNet 50, they are 17 milliseconds, and for the mobile net, around 6-7 milliseconds. Switch time. Often the task is too complex to solve it into one single network. So it is common to split it in a couple of subtasks or sub-networks. So it's also important to know the switch time. How fast can we switch from one network to another? And for the ResNet 50 and MobileNet 2, we have a switch time of around about 0.2, 0.8 milliseconds. MobileNet 1 is somehow a little slower, 2 milliseconds here. At the feature overview, I mentioned the image signal processor of the i.MX 8M Plus already. And this unit is, of course, very interesting for image processing. So let's get a little deeper into that now. First of all, what does an image signal processor do? What do we need it for? Well, it does the pre-processing of the raw image data that we get from a camera sensor. And I put some of the features here on the list, and the probably most significant one is demosaicing, or sometimes also called debayering. So most CMOS sensors have a so-called Bayer RGB color mask. And for further processing, we need to transfer that into RGB values. And this is what demosaicing feature does. And this is something that the ISP can do for us. You can see that here in the upper picture. On the left side, this is how the color mask on the sensor looks like. And what we want is, in the end, what you see on the right side in the image memory, we want 3 planes of colors for each pixel, so a triple of values. Some other functions, for example, are black level calibration, the masking of defect pixels, white balance and color calibration, or high dynamic range processing. And from the optical perspective, lens shade and lens distortion correction, also called dewarping. And this is what we see here in the lower example. On the left side, the raw image of a fisheye lens, how the image sensor actually sees it. And on the right, the same image rectified by the image signal processor of the i.MX 8M Plus. Okay, what's the benefit here? Usually a system architecture would look like the one in the upper diagram. We have a camera which includes the image sensor and the separate ISP, which processes the data, and then the image is sent over the interface to the CPU, which does the actual image processing. And with the i.MX 8M Plus, the ISP is integrated inside the processor. So in the diagram, it moved here to the right behind the MIPC Site 2 interface. And the advantage is, of course, we don't need an extra ISP chip on the camera anymore. This is saving costs and space. Also a side effect, we need to transmit less data over the interface because that's raw data. So that's the benefit here. Maybe we could have the idea to leave the ISP away completely. Maybe our application doesn't need much pre-processing, and that little pre-processing we could probably do on the CPU. That is possible, of course. And in fact, this is done in this way on embedded systems frequently, especially with the demosaicing. But compared to such a software-based solutions, the integrated ISP saves resources on the CPU or GPU, which we can use to increase the system performance in general. One thing that is good to know if we want to use the ISP is that it has to be calibrated to the camera sensor, and for some features also to the lens that is used. And this is something that Phytec offers as a service. So calibration data for some of our board level cameras are already available for our BSPs. And also we can do custom calibration for your individual project if this is needed, as an adaptation to a special lens that you might need in your project, for example. So that was a short overview over one of the latest CPU cores that is very suitable for embedded vision. And next, I would like to proceed to the camera side and show some of the latest solutions here and how they seamlessly connect to our CPU modules, which allows the system designer to develop a customized solution faster and easier. So first, I would like to show our phyCORE interface. This is our solution for MIPI CSI2 camera interfaces, as we have them on the i.MX 8M Plus and other processors. MIPI CSI2 is a modern and powerful camera interface that originated from consumer applications like smartphones. But this has developed over time, and now we have also good solutions here for industrial and professional applications. A lack of the MIPI CSI2 specification coming from that consumer history is that it doesn't define a standard connector. So at Phytec, we decided to design a consistent hardware interface on top of the MIPI CSI2 specification that allows the interchangeability between different camera modules and which is suitable for professional applications. So, and for this phyCORE interface, we are using a 30-pin connector, which allows the use of either a cheap flex foil cable or an FPC cable, which can be used to adapt to other connectors easily. And this connector has dedicated ground contacts for cable shielding. Together with our optimized ground concept we have here on the connector and matched impedance cables, we reach a very good electromagnetic compliance, which I can show here on the next slide. Here on the left diagram is an example of the EMI radiation measured. This was done with our i.MX 8M Plus reference board and the phyCORE camera attached with 15 centimeters cable. And you can see the whole setup has a really good margin to the EN 55011 Class B limits. And we also reach an excellent signal integrity according to the MIPI CSI2 standard, as you can see here on the right side, with this very nice eye pattern measurement on the interface. Yeah, let's have a look on the signals. What's on the cable? First off, of course, the basics that we need for the MIPI CSI2 interface. That's the full 4-lane MIPI data interface here in green, which is capable to transmit 10 gigabit of data, and the I2C control bus that we need to communicate with the image sensor, do the settings of the image sensor. Then we have a strong power supply path with the option to switch between 3.3 or 5 volts supply voltage. And this makes the phyCORE interface compatible to third-party cameras as well. We use 3.3 volts for our cameras, but other cameras use 5 volts, so that can be switched. And pin 5 here allows to detect and switch the voltage automatically. And last but also important, we have 4 multi-purpose I/O pins for real-time signals. Like think of trigger and strobe from or to a camera, and that can go also over this cable without any propagation delay. Yeah, let's have a short look on one of our latest board level cameras, the phycom M Mini. With this phycom M connector, and you can see that here on the right, on the backside view, the upper connector. With this camera, we wanted to build the smallest board level camera for industrial grade S-mount lenses. So the camera has a size of only 18 times 26 millimeters, which is barely larger than the lens holder. And this new camera is currently available with 5 megapixel sensors and in a 1 megapixel global shutter version. Next, I would like to introduce phycom L. So the VPC-SI2 interface allows in practice a maximum cable length of about 15 to 20 centimeters. That's like about this. But what if the application requires a longer distance between the camera and the CPU board? And for this use case, we developed our new phycom L series. phycom L uses FPD-Link 3 to transmit image and control data over a single coax cable. FPD-Link 3 was designed for automotive purposes by Texas Instruments. And here we can reach up to 15 meters cable length. The whole thing is driven by a serializer chip that is integrated here right on the camera board. So no extra board is needed here on the front end, no adapter, and which keeps this solution small and cheap. And because we are using power over coax, no extra power cable is needed. So the power for the camera front end is also transmitted over the same coax cable. And we see a lot of applications where this setup is needed or useful for internal wiring inside a machine. So that's why we were thinking here of a small flexible cable and a connector with a very small footprints. You can see that here, that is like 2 millimeters wide, the connector. So on the receiver side, we need to transfer the data back. So we need a deserializer that converts the signal to VPC-SI2 again. For evaluation, we have a separate add-on board available. But of course, for your serious product, this is supposed to be implemented on the individual carrier board. And of course, there are design guides available if you want to do that implementation on your own. Yeah, so far we have seen a lot of hardware. We haven't mentioned software support yet. You probably know that is a lot of work to integrate a camera driver into a board support package. So the BSPs of our vision computer modules come with the Video for Linux drivers for our cameras ready to use. And the BSP also includes some certain vision middleware, like, for example, OpenCV, Helcon embedded, or TensorFlow Lite for AI applications. Yeah, a topic that is sometimes underestimated in the design process is the camera lens. But the quality of the camera can only be as good as the quality of the lens. And so it's important to select the right camera for the application and the right lens for the application. So what we offer here is support for lens selection. Just tell us some parameters of your project and we will suggest suitable lenses. You can also get samples of the lenses. And we can also go deeper into optical design if that is needed. For example, with special filter glasses, we can even customize lenses in a certain range. And we have our camera assembly service. This means we can assemble customized lens modules to your specification and ship them ready to use. So the advantage is you get the camera ready tailored to your requirements, and you won't need a dust protected environment for camera assembly yourself. So to summarize a little, how can we at Phytec support you to speed up your project? First, according to the make and buy concept with standard components. So Phytec offers more than 30 board level cameras that can be combined with more than 6 of our computer modules that are qualified for embedded vision. All of these components have been matched, so they work with each other out of the box. And matching means, on one hand, that we use standardized board level interfaces that connect the camera modules to the computer boards, like the phyCORE or the phyCORE. And on the other hand, they work together software-wise. And middleware is included in the board support packages, vision libraries, and even more important are the services behind the hardware. I think longevity is very important. So Phytec never discontinues a product as long as the key components are available. Our product change management team ensures that our camera and computer modules are available for like even 10 years or longer. Our software team keeps the board support package up to date. Typically, we issue LTS, long-term stable Linux releases, and provide update patches. A new service that we are starting right now is the so-called continuously maintained BSP. So you are always provided with the latest changes and updates like nightly builds. This can be important. Just think about security patches. Second, Phytec offers support and services for the individual part of your design. So here we have several scalable services. So according to your needs, for the maker type who wants to design the application board on his own, we offer development kits which contain the camera, computer module, a baseboard, complete software ecosystem, and all the informations that you need to design your own application board. And then we have the design support for any stage of your development. For example, we can do software driver integration or just help you at any point you might get stuck. And another thing that I would really like to recommend is to use our design review service. Here, our engineers will have a look on your schematics and the layout of your board, so you can benefit from the design experience and reduce the design risks by this external reviews. Yeah, and if you are the type who likes to focus on your idea and your application software, we offer turnkey design service. And this is basically fully custom designs from specification to production, carefree package. And we can also do the complete lifecycle management for you. Yeah, a lot of information. What would be a good way to start into a project? And I have two suggestions. First, get one of our embedded imaging kits. The kits contain everything you need to evaluate the systems. And actually, the components in the kits are not development hardware, but rather already industrial-graded components that are potentially ready for mass production. So the idea is that you can start very close to the final solution already. And I should mention that we can customize the kits. So if you need a different camera module or a different lens, that's no problem. Just tell us what you need and we can put that together in an individual kit for you. Yeah, and second, we offer free project workshop days for qualified projects. And this means you can talk to our experts about your project and your requirements. And we will show you possible solutions, set up a course specification already, and so on. So this gives us one full day to work on your project together. And of course, we offer this also as online meetings now. Just get in contact with us and discuss your requirements and your project. Yeah, I'm at the end of my presentation. Merci bien for your attention. And now it's time for your questions.
Merci Martine. Je vous invite à nous poser vos questions par le chat ou l'onglet Q&A. Vous avez deux petites bulles qui vous permettent de poser les questions suite à la présentation de Martine.
Yeah, and while you are thinking about your questions, I can also use this time to show you here in the camera the products that I mentioned. Can show it here a little. That is the phycom-L camera. You see that is the size of this camera, and this here is, I hope you can see it, industrial graded. I hope you can see that is the mini version of the camera here, barely larger than the lens holder itself. And we think that this S-mount lenses are really a good selection, a good solution for many applications in the industrial range, because they have a good trade-off of price and performance.
Bon, je ne vois pas encore arriver de questions. Y a-t-il quelqu'un veut-il se jeter à l'eau avec une première question? Ah, je ne vois rien arriver. Bah, de toute façon, si, ça y est. Bah, en plus, elle est en anglais, Martine, c'est merveilleux. What is the power consumption of camera module on Phytec-Allemagne 8 for vision application? Donc, quelle est la consommation de nos produits caméra et de la carte CPU associée i.MX 8M+, j'imagine, pour l'application de vision?
Yeah, for the camera modules, I can say around about 100-200 milliwatts, because here the advantage is that we have on the camera front end, we don't have to have much intelligence, no pre-processing. So the camera itself has a really low power consumption. Depends, of course, on the modes that you are using, like the frame rate and the resolution a little, but round about like a few hundred milliwatts. The computer module, that of course depends a lot on the application, what you're doing. So typically on many applications, we have an average of, let's say, around about 5 watts. Some applications, if you would use all the resources, the CPU, the GPU, and the NPU together at 100%, that can be up to 12 watts for the adult MX8 and Plus. but a realistic would be like round about 5 watts for many applications. I have also an extra slide in the handout where we measured some power profiles. So if you download the I think there's a link, Denis, no, to download the slides later.
Yes.
So
Oui, tout à fait. Vous aurez la possibilité de télécharger la présentation et des slides additionnels auxquels a fait allusion Martine ou des propos qu'il vous a présentés qui n'étaient pas forcément illustrés, en particulier cet aspect consommation, hein, donc qui va plafonner à 5 watts sur la globalité caméra plus carte i.MX, phyCORE i.MX 8M+. Donc, n'hésitez pas à poser vos questions en français. Ah bah, très bien. La question arrive directement en anglais. Donc, do you have any other models in the benchmark for the NPU other than the three shown in the slide? Donc, on nous sollicite pour savoir si nous avons d'autres modèles NPU que les 3 que nous avons présentés en termes d'exemples.
Yeah, also we have measured 1 or 2 other models for a specific customer that was specific on a specific customer applications where they already have trained models, and so yeah, of course the inference times are different. Do you have a special network in mind that you want to know the performance, or was just in general VGG? I don't think we have measured that yet. I will ask our specialist for the NPU and I think we have your email address, so I can come back to you later. And I will find that out if we have measured that.
Oui, on revient vers vous à travers votre demande sur le VGG que vous m'avez émis d'ailleurs en parallèle. Merci. D'autres questions? De toute façon, d'autres questions peut-être?
What I can mention is probably that NXP offers a good solution here to use and to evaluate the neural processor. That's the EIQ, called EIQ Suite. It's a software platform, like a server client platform, where you can configure and deploy your own application, your own networks, even train networks in this platform. So that would be a good starting point if you want to examine if a certain application or the performance of a certain application with this neural processor inside the i.MX 8M+.
Très bien. Y a-t-il une autre question avant que nous closions cet échange et ce webinaire?
Yeah, if there's any more questions, if you have questions later, don't hesitate to send us an email or contact us in any other way. Denis will forward that to me, or you have seen my email also in the presentation. So don't hesitate to ask, please.
Oui, tout à fait. Comme le précise Martine, n'hésitez pas à nous questionner directement, soit par mon intermédiaire, soit par notre boîte d'infos, soit directement sur le mail de Martine par rapport à des questions qui vous reviendraient suite à cette présentation que vous pourrez bien sûr télécharger. On va vous envoyer le lien en suivant. Bah, écoutez, s'il n'y a pas de nouvelles questions, je propose qu'on en reste là ce matin. Je vous remercie en tout cas pour votre attention et votre présence lors de ce webinaire dédié à toute l'offre imagerie embarquée aux solutions que nous proposons pour répondre à des applications de vision dans le domaine de l'imagerie embarquée. Merci en tout cas pour votre présence et votre attention et vos questions. Et puis à très bientôt pour un nouveau webinaire que nous organiserons. Vous retrouverez l'ensemble de notre offre et les produits de l'activité imagerie embarquée sur notre site web. Et puis, vous pouvez nous contacter par les canaux habituels, sales@phytec.fr pour vos demandes commerciales, info@phytec.fr pour des infos diverses et variées et support@phytec.fr pour des questions de support. Merci à vous, très bonne journée et à très bientôt.
Merci bien, bonne journée. À bientôt.
Merci Martine, à
Merci.
bientôt.